In this session, we are going to learn in detail about the scattering of light and the day-to-day life examples where we see this phenomenon. What is scattering of light? You can see here light from the sun emits into the atmosphere and it is scattered by the atoms or molecules of different gases present in the atmosphere. This process is known as scattering of light. The atom or particles that scatter light are called scatterers. We can also say the scattering of light is the phenomenon of bouncing off the light in a random direction by the atoms or molecules of the medium through which it is traveling. The two types of scattering are elastic scattering and inelastic scattering. The scattering of light in which the energy of the scattered light remains conserved is called elastic scattering. The scattering of light in which the energy of the scattered light does not remain conserved is called inelastic scattering. Next point to learn is Rayleigh scattering. Rayleigh scattering is the scattering of light when the size of the scatterer is much less than the wavelength of the incident light, due to which the intensity of the scattered light is inversely proportional to the fourth power of the wavelength of the incident light. You can see here the light from sun, the visible spectrum range is emitted on the earth's surface, and when the light penetrates through the atmosphere, the particles in the atmosphere, that is the air molecules, scatter the blue light from the visible spectrum. Thus, we can see the sky in blue color. Sun and the sky appears whitish at noon. The reason behind this is the scattering of light phenomenon. Let us explain in detail. At noon, the sun is nearly overhead, due to which the light from the sun travels a much smaller distance and the scattering of light takes place much less. Hence, all the colors of the visible light enter the observer's eye, thus giving a whitish appearance to the sun at noon and also the sky. The background picture explains us the reddishness of the sun during the sunrise and the sunset. During sunrise and sunset, the sun is near the horizon. The rays from the sun must travel a larger distance through the dense part of atmosphere to reach the observer. During this course of journey of the light rays, most of the blue lights get scattered away. The red color, which has the highest wavelength among the colors in the visible spectrum, gets scattered the least. Due to this, the light from the sun during sunrise and sunset entering the observer's eye consists mainly of higher wavelengths of the light like red. Thus, the sun looks reddish at the times of sunrise and sunset. At every stage, we can see the danger signals are colored red. This is also the best example of scattering phenomena. One of the colors of the visible light, the red color, has the highest wavelength, as we discussed till now. When light passes through the Earth's atmosphere, it gets scattered from the atoms and molecules present in the atmosphere. As the size of these atoms or molecules is much less than the wavelength of the incident light, Rayleigh scattering is valid. As the intensity of the scattered light varies inversely with the fourth wavelength power, the red color is least scattered. Due to this, the red color can be seen from a maximum distance. Thus, red color can be seen even when there is fog or the atmosphere is not clear. This is the reason the danger signals are given red. Next example is sky always appears dark to the astronauts in space. When astronauts in space look up towards the sky, they look at the vacuum in the space. There is no atmosphere in space, so there are no particles in space that can scatter light. As no scattering of light takes place, no light enters the astronauts' eyes in space from the sky, and hence the sky appears dark to them. The background picture is one more example for the scattering of light phenomenon. The path of the light becomes visible in the canopy of a dense forest. When sunlight enters the canopy of a dense forest, tiny water drops in the mist scatter light. Due to the scattering of light, the particles suspended in the atmosphere shine, and thus the path of light becomes visible to the observer. Such a phenomenon is also visible in a smoke-filled room where the smoke particles become visible due to the scattering of light by the particles suspended in the air of the room. The next example, which happens in our day-to-day life, is aerosol effects on climate. Aerosol is the solid or the liquid particles present in the atmosphere. An aerosol is a suspension of fine solid particles or liquid droplets in air or another gas. Aerosols impact climate through direct scattering and absorption of incoming solar radiations and trapping of outgoing long wave radiations, as well as through alteration of cloud optical properties and the formation of clouds and precipitations. Strongly absorbing aerosols have a warming effect. These aerosols, that is, the fine solid particles or liquid droplet suspensions present in the atmosphere, are main reason for the global warming or the cooling of the atmosphere. Thank you for the session.